Hello everyone, how are you? I hope you all are doing good. By the way, welcome to my YouTube channel Physics in a Nutshell, and as always, if you're just new to this channel, do subscribe to my channel, and if you just like my way of teaching, hit the like button. Okay, by the way, today we're going to solve some problems regarding the lesson gravitation. Till now we actually maybe in two parts we have actually understood the concept of the lesson gravitation. Okay, starting from the why we needed that gravitation, okay, how Newton actually observed the phenomenon of the gravitation, till the Archimedes principle. We have actually covered all the things in the lesson gravitation. Right now, using those concepts, now we are going to solve some problems that is in your Ncert solution or Ncert exercise. Okay, first we will solve all these problems in your Ncert exercise. After that, when all the lessons of your physics will completed, we will gonna solve some extra problems from every lesson part by part. Okay, so let's start the video. Okay. Now this is our first problem. Okay, this is our first problem in the gravitational lesson. This is the problem number 12. That problem is actually saying that gravitational force on the surface of the moon is only the 1/6 as strong as the gravitational force on the earth. Now what is the weight in newtons of 10 kg object on the moon and on the earth? See, first thing actually given, that is the thing. Okay, we have to write solution. What we know that weight of the object, or any object, you can consider weight of the object in moon, okay, is equal to, see, I actually explained you that, and we actually showed, or we actually proved that weight of the object in moon is 1/6 time the weight of the object on the earth. Weight of the object, okay, on earth. Right now, we will actually consider the weight of the object in moon, that's Wm, and weight of the object on earth we will consider as We. Right? This is a fact. Again, what we have to do, we will consider that acceleration due to gravity, due to gravity, as g equal to what? 10 meter per second square. It is 9.8 meter per second square actually, but for our convenience, okay, when we will solve the problem, we will consider g equal to 10 meter per second square. That is also not wrong. But if in the question it is mentioned like that, g equal to 9.8 meter per second square, you have to consider that g equal to 9.8 meter per second square. Except that you can consider the g value as 10 meter per second square. Okay. Again, we know one fact that weight of an object, okay, W is what? Mass into what? Acceleration. Okay. That is the main relation that I am going to use, right? So first we'll consider that We, that is the weight of the object on earth. That is what? Mass is given how much? 10 kg. So you can actually write it down here. Mass comma m equal to how much? Given it is actually 10 kg, right? So mass is given how much? 10 kg. Okay. And what is the acceleration that we have considered? G equal to 10 meter per second square, right? 10 meter per second square. Now you can actually multiply it 100, right? 100 kg meter per second square, right? Now, so 100 kg meter per second square. So again, what is that unit known as? Kg meter per second square. That kg meter per second square is known as 100 Newton. That kg meter per second square is known as what? Newton. Okay, that is kg stands for mass and meter per second stands for acceleration. That mass into acceleration gives us what? Force, and the unit of force is what? Newton. Okay, now that is the weight of the object on earth. Now we have to check the weight of the object on moon. Okay, so that is denominated by Wm, and we got the relation that Wm equal to 1/6 times weight of the object on earth. Simple concept. So what is going to be there? 1/6 into, that is 100 Newton. Okay, that is 100 Newton. Divide it, what you are going to get? You are going to get 1/6. Okay, after that 6, after that 7, 16.67 kg meter per second square equal to 16.7. You can actually consider Newton. That is the weight of the object in moon. Okay, that is what? Weight of the object on moon, and that is the weight of the object what? On earth. So there is a difference, right? That is 100 Newton, and that is the what? Weight of the object in the moon as 16.7 actually Newton. Okay, if you want to check, just multiply this 16.7 with 6. We know that 16 into 6 equal to what? 96, and almost 0.7s are there. So you are going to get 7×4, that is almost 100 Newton. So right, so what we have got it? We know that Wm equal to what? That is the weight of the object on moon as equal to what? 1/6 times the weight of the object on the what? Earth. So it is not satisfied, right? So that is a solution of that question, and it's a quite simple question. Okay, right? Now we are going to move towards our next question. This is our next question. What this question actually saying that a ball is thrown vertically upward with a velocity of 49 meter per second square. So let me draw it first. Okay, this is a person which is actually sitting here or the standing here. He just thrown a ball in the upward direction. Okay, with a velocity of it is going to be what? Initial velocity, right? Always remember that if whenever it is mentioned that a ball is thrown upward with a velocity of 49 meter per second square, always consider that it was initial velocity. Okay, that is E equal to how much given? 49 meter per second, right? Then what we have to calculate actually that a maximum height to which it rises actually, right? Now we have to calculate that much height, that what to which it actually rises, that is the h. We don't know what is actually h. And secondly, the total time it takes to return to the surface of the earth, right? That means we have to calculate that how much time it actually take to reach the ground again. Okay, so we will solve according to that. First we will solve the first question, but before that we should actually write it down what is actually given, right? So what is actually given as a solution? Given u how much? 49 meter per second. Always remember one thing, that if the units are actually different, that is it is given in kilometer per hour, then you have to actually convert to meter per second. Now it is given in meter per second, so we don't need to convert anything. So it will be like that. Okay, so we have got that 49 meter per second, right? Now we know that g equal to what? 10 meter per second square. So in the first case, what you have to calculate the maximum height, that is h equal to question mark. So we will use equations of motion that we actually get. That equation that we are going to actually use is going to be what? We know, now we don't need to write, we know v square minus u square equal to what? 2gh, right? That is the first equation of motion that we are going to actually use. Here, by the way, here, once it reaches the maximum height, here what is going to be 0? That final velocity going to 0. Then it is going to rest for certain second, then again it will start falling downward, right? So what we can consider here? V equal to 0. So what we have to actually write here? V equal to what? 0, right? Now, so here that term will be 0, and what is actually u is given? 49 square, right? Again, the fact is 2 into, see, the ball is now moving towards the upward direction. That means that acceleration is due to gravity is to against the gravity. Gravity always acts towards the downside direction, but now ball is moving upward direction, right? In this direction. That means the ball is acting against the gravitational force. So what is actually going to happen? That acceleration is going to decrease a little bit, right? That means it is a kind of retardation thing. So what is going to be there? That acceleration is going to be what? Negative. That is minus 10. Okay. Now I have to calculate the height. So that minus and that minus is going to be cancelled out. So what is going to be there? H equal to 49 square into 2 into 10. That 49 square, if you just solve, you are going to get 2401 by 2 into 10. So again I am going to solve this little bit. 240.1 by 2. If I divide 2401 by 10, we are going to get like that. Now to again divide it by 2, what we are going to get? 120.5. Right? Yes, 120.5 meter. That is the what? Maximum height. That is h max. Okay, that is the maximum height it actually attains, 120.5 meter. That is the first question actually solve, right? So now what we have to check? We have to check in the second part what is actually asked. In the second part, what we have to calculate? We have to calculate total time it takes to return to the surface of the earth, right? We have to calculate the time. So what we will use? We are going to use one simple formula. That is what? V equal to U plus GT, right? So here the V is 0 as we have considered the V equal to 0, right? So it is going to be what? 0. Now what is the value of U is given? 49, right? Again we know that G is going to be what? Negative, that is what? Minus 10t, right now? So we will actually arrange that. What we are going to get? 49 equal to what? 10t, right? So what is the value of t is going to be what? 49 by 10 second, that is 4.9 second, and approximately you can actually consider that is what? 5 second. So this is the actually solution of this equation, of this question, right? So it actually asks two things to calculate. That is the first, the maximum height to which it rises, that is the maximum height, that is 120.5 meter. And now then the second question, it actually asks to solve that the total time it takes to return to the surface. So this is the solution of the time, okay? That is the main solution. Okay, now we are going to move towards our next question. This is one of the most easiest question. Okay, what is really given that a stone is released from a top of the what? Top of the tower of height 19.6 meter. That means if it is a tower that we are going to actually consider, okay, if the ball is reached from that height, that is how much height it is? 19.6 meter, right? Now the height is only given as 19.6 meter. So we have to now calculate this final velocity just before it touching the ground. See here, one thing is going to be 0, that is the initial velocity, because it is now rest, right? So the u is going to be 0. So we have to calculate the velocity just before touching the ground. But one thing you have to be very much careful about that. Once it reaches the ground, its velocity, that is the final velocity, is also going to be 0. But we need to calculate the velocity, that is the final velocity. It is mentioned now, the final velocity. So if it is mentioned as the final velocity, you have to calculate what? P. But before touching the ground, okay? If the ball is moving like that, okay? Just before touching the ground, you have to calculate that velocity, right? So what we have got? We have got that u equal to how much? 0 meter per second. You can actually take. And what is the height is actually given? 19.6 meter. Again, since it is related to gravity, we can consider the acceleration due to gravity as 10 meter per second square, because the value of g is not mentioned in the question. So we can consider this g as 10 meter per second square. So we need to calculate what? The final velocity. Simply we are going to use one formula. That is what formula we can actually use? V square minus u square is going to be what? 2gh. Here u is 0, right? So not u is 0. Yes, u is 0. So we have to calculate v square minus 0, because u is 0, so u 0 square is going to be 0. Again, now the fact is, since the ball is moving downward direction, so z is going to be what? Positive. So the whole thing will be as same as like that. 2 into 10 into 8. What is the height is actually given? 19.6 meter. Not I will give the unit. Okay. So that is the fact. So v square is going to be how much? 2 into 196. Okay. So again we have to multiply it. V square equal to 392. So now we have to calculate the what? You have to take the root over. So the unit is going to be what? Meter per second. If you take the square root of this 392, you are going to get 19.79 meter per second. So that is the final velocity. Okay, that is the final velocity that a ball is going to acquire before touching the ground. So quite simple question. Just write this down question, and we are going to move towards our next question. And this is our next question. This is a question number 15. That what this question is actually saying, that a stone is thrown vertically upward. So it is moving in the vertically upward direction. So what we are going to consider, g is going to be what? The g's value is going to be what? Negative. Simple fact, because it is actually moving upward direction. Now initial velocity is given, that is u is actually given, and here the z is actually already given, that is the 10 meter per second square. And we have to find the maximum height reached by the stone, that is the maximum height with the velocity u is going to be reached, or it can go to take, or it is going to actually attain the maximum height. Okay, now we have to again calculate the net displacement. Here one more new thing we have to actually calculate is a net displacement and the total distance. Okay, so let me first actually draw a figure. So first, consider this is a person that is actually sitting here or just standing here. He just thrown a ball upward. Okay, it actually attains at this much height. We have to calculate that height. Okay, with a velocity of how much actually given? U equal to 40 meter per second. Okay, after attaining the maximum height, what is going to be 0 there? V. Okay, so we are going to use that concept V equal to 0 and U equal to 40 meter per second to calculate that height. But the fact is, once the velocity becomes 0, that is the final velocity, that is V is going to be 0, what is going to happen? It is again going to fall in the downside direction. So it will start falling to this height. So in the second thing, or in the second case, what we have to calculate? The total distance and net displacement. So simple fact that what you can actually draw from here, that since the displacement, to calculate the displacement, initial point and the final point become similar, so what is going to be the net displacement? Simply 0. Because if in case of a displacement, if the initial point and the final point always becomes the same position, the displacement is 0, right? So it is a vector quantity. And what we have to calculate? Max total distance. See, we have to calculate the distance from where it will actually move towards that height. Again, it will fall to the same position. So it is going to be what? Summation of the two heights. Then we are going to get the what? Total height. Now we will actually solve it. So first, we will write down what is actually given. Given U equal to what? 40 meter per second. And it is the Z value is given. Z equal to what? 10 meter per second square. And we have to calculate the height. So again, what we are going to get? V equal to 0. So from question, okay, or you can actually write V equal to 0. So now we are going to use that formula. That is not, what is the formula? V square minus U square is equal to what? 2ZH, right? So here the V is equal to 0. So here U is actually given as 40. So minus 40 square is going to be what? 1600. Okay. Since the ball is moving upward, so Z is going to be what? Minus, that is actually mentioned here, that is going to be negative. 2 into Z's value is given as that minus 10. And H, we need to calculate the H. So that minus and minus are going to be cancelled out. So what is the H value is going to be what? 1600 by 20 meter. 2 get cancelled. 80, that is 80 meter. We are going to get the height as the what? 80 meter. Simply height, that means the ball traveled to that distance, to that position, the height was what? 80 meters. So what you can say accordingly, that the ball traveled a distance of 80 meter. Okay, I'm just gonna name some. This is the A position, this is the B position, right? 80 meter to reach B, right? Again, it will reach from B to A, right? So the total distance is going to be what? 80 plus 80, right? First, the ball will reach from A to B, that is the 80 meter. Again, it is going to be reached to B to A because it will start falling, right? So 80 plus 80 meter. So the total distance is going to be what? 160 meter, right? Simple. Now what is the displacement is going to be? Net displacement. Since initial position is equal to final position after reaching ground. So what we can say? I don't need to give that. Net displacement is equal to what? 0. Because initial position and final position is going to be same. So net displacement is going to be what? 0. So that is the solution of this question. Now we are going to move towards our next question. Okay. Okay, this is our next one. That is the question number 16. Okay. The 16 number question actually says that calculate the force of gravitation, that is the F due to gravitation, between Earth and the Sun. That is the Earth and the Sun. Given that the mass of the Earth, we will write it down first. Mass of the Earth ME is given as how much? 6 into 10 to the power 24 kg, right? And that of the Sun, that is the mass of what? sun is given as how much? 2 into 10 to the power what? 30 kg, right? Again, what is really given? The average distance between the two, that means the between Earth and Sun, that is the average distance, is given as how much? That is R is going to be what? 1.5 into 10 to the power 11 what? Meter. Okay. Again, whenever you have to calculate the forces due to gravitation, we need one constant, that is what? G. That is the universal gravitational constant. Its value is given as how much? It's not actually given that, but we have to keep it in mind, or we have to actually memorize it. 6.7 into 10 to the power minus of 11 Newton meter square per kg square. That is the value of the what? All the things that we are going to need to calculate the force of gravitation. That force of gravitation have a formula what? F equal to G. M1 M2 by R square. Here we will consider the M1 as ME, that is the mass of the Earth, into mass of the Sun, that is the MS by R square. Simple. Now we will put all the values. Okay. So what are the values actually given? The value of G is how much? 6.7 into 10 to the power minus of 11 into. Okay. What is the mass of the Earth is given? 6 into 10 to the power 24. Mass of Sun is actually given 2 into 10 to the power 30, right? And what is the R is actually given? 1.5 into 10 to the power 11 whole square. All the values are actually given. Since that we need to calculate the force, so the unit is going to be what? Newton. Simple fact. So first what we are going to do, we are going to actually solve the powers, that is the 10 to the minus of 11, 10 to the minus of 24, 10 to the minus of 10 to the power 30. So here 10 to the power 11 whole square. So we want to actually arrange all the powers. Again, we are going to arrange all these things. Okay. So what is going to be there? 6.7 into 6 into 2 equal to 12, and 1.5 whole square. 1.5 is whole square is going to give us 2.25 into. Now we are going to arrange all the powers. Okay. So here it is 10 to the power minus of 11. It is 10 to the power 24. It is 10 to the power 30. Right. And it is 10 to the power 11 whole square. So it is going to be the what? 10 to the power 22. To arrange all the formulas, we have to use one general term. That is one is what? If a to the power m, it is a to the power n. That actually leads us to what? A to the power m plus n. And a to the power m by a to the power n, it is going to give us a to the power m minus n. That is the two main formulas that we are going to use to solve this type of things. Okay. And that term, if you solve, you are going to get 35.7. Because I have already solved, so I know. Simple fact. I'm not going to lie. Okay. This is the thing. So we are going to solve something 10 to the power minus of 11. If you solve this thing 10 to the power 24 and 10 to the power 30, we are going to get m plus n. We are going to use 4, 54 and 10 to the power 22. Again, further, if we solve, what we are going to get? 35.7 into 10 to the power 21 Newton. Okay. So that is the solution of this equation. That is what we can say. The force of gravitation is going to be what? 35.7 into 10 to the power 21 what? Newton. So that is the solution of this equation or that question. Now what we have to calculate? For it is the mass of the Earth is given, mass of the Sun is given, the distance between, the average distance between Earth and Sun is actually given, that is what? 1.5 into 10 to the power 11 meter. And we know the value of the G, that is the universal gravitational constant, which is given as 6.7 into 10 to the minus of 11 Newton meter square per kg square. So now we are going to use all these, we have actually used all these values in the formula. This is actually, we know that F equal to what? G into ME into MS, that is the mass of the Earth into mass of the Sun by the R square. R is the distance between what? Earth and Sun. So we have put all the values, then we get the force of gravitation. You can also write like that, okay, if you want. So it is going to be like that. There is a 35.7 into 10 to the power 21 Newton. Simple question. Now we're going to move to our next question. First, just write this down. Okay. This is our next question. This is a question number 17. It is going to be one of the important question, okay, for us or for you to understand the whole concept. Okay. See, what that question is actually saying, that a stone is allowed to fall from the height of, from the top of the tower, this is 100 meter high. right? So, and at the same time another stone is projected vertically upwards from the ground with a velocity of 25 meter per second, right? Now we have to calculate the when and where the two stones will meet. See, the fact is, first we are going to draw one figure, okay? So consider this is a tower, okay? And from the top of the tower, that is the whole height of the tower is how much? 100 meter, right? So in the first case, it is actually saying that a stone is allowed to fall from the top of the tower. That if this is the top of the tower, so a stone is allowed to fall like that, okay? So at the same time, another stone is projected vertically upward. So at the same time, okay, at the same time, a stone is thrown vertically upward, like that, okay, with a velocity of how much it is given, u equal to, that is, it is obviously going to be what? U equal to what? 25 meter per second. Okay, now we have to calculate when and where the stones will going to meet. That means if they are moving in the same line, right? Okay, they are going to meet like that, huh? But we have to calculate when and where. So we have to calculate the height, right? The height at which the two balls is going to meet, or at the time when they are going to meet. Simple question, but to solve this question we have to actually consider two sets of cases, right? So what we will write as like that, okay? First case, okay, solution. But actually before writing the first case, we will actually write down what is actually given. So height is actually given as how much? 100 meter, right? Okay, that is the fact. And we will, what we will consider? We will consider the time, since the time is same for the two objects, and for the two cases we will consider the t second. Okay, so now we write the first case. Okay, so when the ball have to fall downward, right? Here the ball is falling downward direction, so what is the value of g is going to be what? Positive. So since the ball is falling downward, so g is what? Simply we'll write at what? 10 meter per second square, so that you can actually, it will be actually easy to solve the equation if we consider g as 10 meter per second square. That's the fact that we are going to actually consider 10 meter per second square. So yeah, now we will use one relation. We need to find out the what? Distance or the height, right? We need to mainly calculate the height because we need the position. Here you have to calculate the height. So then you are going to get the position. You will actually understand that. So we are going to use the formula as S equal to what? Ut plus half of what? Gt square. But the fact is, once the ball have to fall, here the ball have to be at what? 0 meter per second square, is 0 velocity. So here what is going to be there? U is going to be 0, because see, if I just drop a ball from that height, first it is at 0 velocity, right? That is, your initial velocity is going to be what? 0. Then here it is going to attain or get some velocity. That is going to be what? Final velocity. So here U is going to be 0, right? So that time is going to be what? 0 plus half of, since it is moving downward direction, so what? This is going to be what? 10, the value of g is 10, and t square. We don't know that t, so you have to calculate. So if you solve it, what we are going to get? 5 t square, right? And what is in case of the second case? Second case, now the ball is actually moving with a velocity, that is u is actually given, right? U is given how much? 25 meter per second. And here g is going to be what? Minus 10 meter per second. So because it is moving or acting against the what? Gravitational force, so g is going to be what? Negative. Simple fact. Again, we will use that same relation because it is related to what? Height. So we will consider S1 or S dash. You can consider this S, it is S1. So here ut plus half of gt square. Now the height is, u is actually given, so what we can write? 25 t square, right? And minus, since g is negative, so 10 t square, that is 5. So what you can write? 25 t square minus 5t square. We get two distance, that is first distance, are given s1 and make it as s2, not s1 and s2. Now the fact is, first distance s1 is going to give us that height, okay, that is the s1, right? And the second s2 is going to give us what? That's s2. Now the fact is, from the figure it is quite clear, if we add s1 plus s2, we are going to get this what? 100-meter height, right now, right? So if we consider that this is a path from A to B, okay, if somebody travels this distance at how much? 10 meter, okay, and if it is traveled 90 meter, and we know that the total distance between us 100 meter, so what is actually what we can say, that s1 plus s2 is going to be what? The total distance, that is 10 plus 90 is going to be what? Equal to 100. Similar to that, okay, if the ball is now first distance is s1, now it is s2, they are going to meet a certain position that we don't know, we have to calculate that. So when we will add, we will get the what? 100-meter distance, right? So we will actually now say that, right? So according to the question, what you can write, s1 plus s2 equal to what? 100 meter. Alright, now put the values of s1. S1 we have got 5t square plus, what is the value of s2? 25t square, okay, minus what? 5 of t square is equal to what? 100 meter. Now it is the 5t square minus 5t square, so they are going to be cancelled out, right? So not 25t square, it should be 25t, okay, this shouldn't be 25t square, this should be 25t, okay. So 25t equal to how much? 100 meter. So from here we can actually calculate the required value of time that we are going to actually need, right? It actually asks now when, that means what? We have to calculate the time, right? So here what is going to be time? T equal to 100 by 25 is equal to what? 4, okay, second, okay. So what if to calculate? The time is going to be what? 4 seconds. So we get the time 4 seconds, okay. After traveling for almost 4 seconds, the ball is going to what? The two balls is going to meet. Now we have to calculate the height, right? We have to calculate the height. So for that, we are going to consider the first s1. That means how the first ball is going to, how much the first ball is going to move, okay? What is the distance it is going to actually travel, okay? So we'll calculate that from that equation. Hence s1 is going to be what? 5 into t square. That is t is how much given? 4 seconds. That is 4 square. That means how much going to be 5 into 16. Okay. So we are going to get how much? Actually 16 5 into 80 meter. Okay. That means what you can say, the ball had to travel or had traveled 80 meter distance from here to that position. Now if we have to calculate the where the ball is going, two ball is going to meet, simply what we have to do, we have to subtract that 80 meter from the 100 meter, right? Then we are going to get what? The position where the second ball have that height, the second ball have traveled. So what we can write, the position where the two ball have meet or met is going to be what? 100 minus 80 meter, that is what? 20 meter, right? 100 minus 80 meter is a 20 meter. That means what we can say, 20 meter from the ground, not from the upside direction, from the height of the tower. See what now, what actually we can say, that was the tower, right? That was the tower. So what we can say, when the ball, whenever you have to measure the height, we have to always measure from the ground, not from the top of the tower. Okay, so what you can say, the first ball, that is the second ball, which is actually moved from the ground, it actually travel how much distance? 20 meter. Okay, and when the ball, when it moved from the tower, it actually attains a height of how much, or it travels a distance of what? 80 meter. Okay, so that is the position, that is the 20 meter from the ground or 20 meter above the ground, the two ball is going to meet. Okay, so that is the position that we actually calculate, and to occur that thing, it actually took 4 seconds. Okay, that ball move for 4 seconds to actually attain the distance of what? 80 meter, and that the ball which is actually moving upward, it actually took also 4 seconds. What then? Because at the same time it actually traveled simultaneously at the same time. So the 4 seconds is going to be same for both the two balls. So at the 4 second, they have actually the ball travel 80 meters, second ball travel 20 meters. But since we always measure the height from the ground, so we will consider 20 meters as the position where the two balls is going to meet. So that is the solution of this equation or this question. So now we are going to move towards our next question. This is our next question. That it is the question number 18. What this question is actually saying that a ball thrown up vertically return to the thrower after 6 seconds. That means a ball is thrown from first throw vertical upward direction. Okay. If it is a position, first it thrown vertically upward. Okay. After that it returns to the thrower. That means if I thrown a ball upward, it is going to return to me, right? Like that. Okay. After what? 6 seconds. But the fact is that 6 seconds you have to actually divide. Okay. See, whenever we throw a ball upward, okay, the time of ascending, that means when the ball is moving upward, is going to equal the time of descending, right? That when the ball is moving, is going to move downward direction. That is not the time of ascending and time of descending. Okay. So when the ball is moving first upward and then downward, it will take 3 seconds. Again, when it was moving in the downside direction, it will again take 3 seconds. That's why it is actually given as 6 seconds. So what you can say, the time of ascending is equal to time of descending, right? So that's the fact. So based on this thing, we have to actually calculate. Now we have to calculate the velocity with which the ball is actually thrown up. That means we have to calculate the u here. And here for the first case, to reach that height, the v is going to be what? 0. Again, we know the time, right? So you will use the relation, that is v equal to what? U plus gt, right? So here the velocity v is 0 and we need to calculate the u. And since the ball is moving upward direction, so we can consider the value of g as minus 10 and time is given as how much? 3 seconds. Okay. We don't need to write that. Okay. We will keep the 3 as it is. Okay. So what we are going to get? 0 equal to u minus 30. Right. So we are going to get u equal to what? 30 meter per second. That means the velocity with which it is actually thrown up is going to be what? 30 meter per second. That is the first question. Now what is the second question? It actually asks the maximum height it reaches. Okay, we need to calculate the height. So for that we get the u as how much? 30 meter per second. And for that v is equal to 0, we need to calculate what? H. Okay, again since g is going to be what? Minus 10 meter per second square. So for that we will use the relation v square minus e square equal to what? 2gh. Here v is 0, so it will be 0. U is given as how much? 30. So 30 is going to be 900, right? 2 into minus 10 into h. Okay, so h is going to be what? 900 by 20. See, that minus and that minus is going to be cancelled out, right? So that 0 is going to be cancelled out. We are going to get 45 meter. That means with the velocity u, that is 30 meter per second square, it actually attains a height of how much? That height is going to be how much? 45 meter. Okay, that is our second question. It's quite simple question, nothing to be explained here. We get the first u equal to 30 meter per second square. Then using that initial velocity, where the final velocity is going to be 0 because it is going to stop here. After that ball stop, it is going to fall down again, right? So here the v is going to be what? 0, right? And using that u equal to 30 meter per second, v equal to 0, we can actually calculate the height to which the maximum height it can actually attain. That height is always considered the maximum height. After that, attaining maximum height, it is going to again fall. Simple. So that is the maximum height. Now what is given in the third? It is little bit, we have to actually consider or we have to actually observe. What is the saying? The position after 4 seconds. Okay, after moving 4 seconds, okay, what will be the position? That means we have to calculate the position, but the fact is the time 4 seconds, right? Here the time was given as 6 seconds. That means then what we did, we actually did that it will move for 3 seconds. Again after that it will move downward for 3 seconds. It divided it, but here the time is given as what? Time is given as 4 seconds. But we see that the first 3 second time it actually need to move upward or to attain the maximum height, right? So of that 4 seconds, that 3 seconds will be used to attain that maximum height. So what is the time actually left? 1 second. So in that 1 second it will start falling. That means what we can say, of that 4 seconds, the 3 seconds will be used to attain that height, that is the 3 seconds. So how much time actually left? 1 second. So in that 1 second it will actually fall. Understand now? So because we have actually first we consider that it actually took 3 seconds to attain a maximum height. So of that 4 seconds, 3 seconds is going to be used in the same way, right now. So we are going to use only 1 second. So whenever you have to calculate the position, we will use that relation ut plus half of gt square. Since the condition is going to be satisfied only for 1 second, and the 1 second it will start falling. So when it will start falling, here u will be 0, because for that time the initial velocity will be 0, then it will attain some what velocity. So what we can say here, that time will be what, 0 plus half of, since the now ball is moving downward direction, so the z will be positive, that is 10, and what is the time? 1 second. Okay, so the total time is going to be what? 4 minus 3 second is going to be what? 1 second. Okay, so what we can write? 5, that is the 5 meter position. That means when it starts falling, it will be cover a distance of 5 meter. It actually asked us the position after 4 seconds. So what is the position? Whenever you have to measure the position, we have to actually measure from the ground. Okay, so it actually travel the distance of how meter? 5 meter. So now what is the total height? 45 meter, right? The whole height was almost 45 meter, right? So what will be the position? The position will be 45 minus 5 meter is going to be what? 40 meter from the ground. You have to actually mention that from the ground. That means it will say that you have actually measured from the ground, not from the what? Top of the tower, right? So that is the answer of this question. Now we are going to move towards our next question. Okay, this is our new question and the last question of our today's class. Okay, what this question is actually saying that a 5 gram of sealed packet, okay, that means the mass is actually given, okay, 500 gram, sorry, 500 gram, is the volume of a 500 gram sealed packet is 350 gram per centimeter cube. That means the volume is actually given 350 gram per centimeter cube, right? Now the first question is, will the packet float or sink in the water if the density of the water is what? 1 gram per centimeter cube. That means rho of water, right, is going to give us what? 1 gram per centimeter cube. Now the fact is, when we actually discuss the buoyancy and the Archimedes principle, if something have to be float on water, okay, what we actually said that object's density, okay, have to be lower than the density of the water, then that object is going to float on the water. Okay, here density of the water is given as what? 1 gram per centimeter cube. Okay, to float that object, that or the packet on the water, the packet's density have to be smaller than the density of water. Then only that packet is going to float on the water. Simple fact. So for that, we are going to first calculate the density of the packet. So mass and volume is given. It is quite simple to calculate the density. So the density of the packet, okay, rho p, that density is always actually represented by rho. That is the symbol rho, right? So we will write it properly. Rho p is equal to what? Mass by volume. And density have a formula. Density, I think you know it. Density equal to what? Mass by volume. That is the formula. The mass is given as how much? 500 gram. Okay, and what is the volume is given actually as 350 centimeter cube. Okay, now we have to calculate the volume. So we can cancel the zeros. Now 5 10 times, 5 7 times, that is 10 by 7 gram per centimeter cube. So it will be almost 1.428 gram per centimeter cube. Clearly that rho p is greater than rho w. That means the density of the packet is greater than the density of the water. So what we can write? The packet will sink. Since the rho p is greater than rho w, the packet is going to sink. It is not going to float. In the second case, it actually asks that what will be the mass of the water displaced by this packet? Okay, when we will actually keep the packet on the water, due to its weight, it is going to displace some amount of water by the Archimedes principle, right? So you have to calculate that mass of that weight, mass of the water. We know now density equal to what? Mass by volume. So mass will be what? Density into volume, right? Here we have to actually consider one thing very carefully, that since here we have to calculate the mass of the water which is actually displaced, right? So for that, the density is going to be the density of the what? Water. We know the density as how much? 1 gram per centimeter cube. When the water will displace, okay, it will be displaced by the what? That packet, okay, and the volume of that packet was given as what? 350 centimeter cube, right? 350 centimeter cube. So 350 centimeter cube. That centimeter cube and that centimeter cube is going to cancel. So only what will remain? 350 and 1. So 350 gram. So what you can write? The mass of the displaced water is 350 gram. Okay, so that's the fact. So if we have to understand that, okay, if we consider that this is a bucket full of water, again that is a packet of what? Something object, right? So it will have a something mass that given as what? 500 gram. Again it will have a volume of how much? 350 centimeter cube. So we can calculate the density of that packet. We have got 1.428. Since the density of that packet 1.428 is higher than the density of water, okay, 1 gram per centimeter cube. So what is going to happen? It is not going to float here. What is going to happen? It will sink. I don't say that it will going to reach the ground of that bucket, because it is going to actually what? Sink. That is, it is going to what? Deep into that water, right? That is a fact. Now in the second case, what we have to calculate? When the actually packet actually sink, it have to actually displace some amount of water, right? Now we have to calculate the amount of water that actually displaced, that mass of that water. So we will use that relation, because we know that density is what? Mass by volume. So mass is going to be what? Density into volume, right? So whenever you have to calculate that what? Water displacement, right? The mass of the water displacement, we have to calculate the density or consider the density of the what? Water. That is 1 gram per centimeter cube, right? And volume of that packet, because of that volume of the packet, the water is going to be displaced. So that volume of that will be is of that packet. That is what? 350 centimeter cube. So what we have got? 350 gram, right? So that is the solution of the equation. And based on this question, you can actually solve 21, question number 21 by yourself. So solve it and send me in the answer. Okay, that is your quiz question. Okay, so solve it and give me one proper reason. Okay. First, let me write it down. Okay, so I hope you have actually written down. Okay, so for today, you are going to have one quiz question. That question is going to be what? Your Ncert book. Okay, page number 145 and question number 21. You have to solve. Okay, and give me proper reason why of that question, of that answer. Okay, I need proper reason. Use that whole concept of this equation, of that question, and use that in the question number 21 and answer me in properly in my what? Comment section with proper reason. Okay, I need a proper reason, and I'm gonna consider those students as the winner who will give me the proper reason with proper solution. Okay, so simple question it is. Try to solve it and give me answer in my comment section. Okay, so this is the end of this class, and in today's class we have actually solved so many problems regarding your Ncert exercise, and now it is your duty, so you just write all the problems by watching the video in your copy. Okay, so it will gonna help you for your exams. So yeah, that is the end of this question. So for now or until now, if you have liked the video, so for whatsoever reason, hit the like button and subscribe to my channel again. I'm just actually repeating it. So it is going to give me what? Encouragement. So and that encouragement will lead to what? For making this kind of videos again and again. So I'm gonna make these videos again and again till I have Jan in my body. So yeah, that's the fact. So stay safe, stay healthy, okay? Stay in your home, don't need to go outside if it is not needed, okay? So yeah, so this is the end of this class. We are going to meet in the next video, okay? In the next video, we are going to start one more new lesson because here our lesson is ended, okay? So we're going to start one new lesson in the next video. So till then, stay safe, stay healthy, keep studying. Bye-bye.